Hello everyone, this is Mr. Slomka, and today what I wanted to talk to you about was section 11.1, part 1, which is on normal distributions. So normal distributions is going to be a topic that we'll spend quite a bit of time on, and we'll be talking about it for a couple of lessons. And so today is very much an introduction to that. We're going to start slowly. So we're going to start very slowly by revisiting a very old topic that actually has nothing to do with normal distributions, but will come into play. What I want you to do right here is I want you to see if you can label and shade a quick number line for me. So what we have right here is we've got this little inequality with these signs in there, and I want to make sure that you remember what those signs mean, because if you don't, you're going to struggle today. And so I want to make sure that you can remember those so you don't have to struggle, because that's no fun. Nobody likes to struggle in math class. So I've labeled my number line right here with a couple of values, and now I want to take a look at what I've got written down right here. These signs right here are less than or equal to signs. If they looked like this, they would just be less than. These ones would be greater than or equal to, and these ones would just be greater than signs. So I need you to make sure you remember those signs and the names for them, because it's going to help you out in a big way. So let me read this for you. This says -2 is less than or equal to x is less than or equal to 4. Notice how the x right here is in between the -2 and the 4. When we graph this, we're going to be locating the -2 and we're going to be locating the 4. And I bet you remember that just drawing those dots isn't enough. You need to shade somewhere. And just like the x is located in between the two numbers, so is our shading. Every number on the number line that is underneath our shading right here is an answer to this old review question. These numbers exist between -2 and 4, and they are the ones that I am interested in. That's a very old topic, and it seems a bit unrelated, but it will help you out. Let's take a look at some graphs. So now I scoured the internet to find these graphs for you, and what they are going to do is they're going to give you some information that is pertinent to your life, and I want you to take a look at them and see if you can find a relationship between the two. The first graph right here is about GPA and the frequency, or the number of times that GPA is achieved. And so you have little or small GPAs like 1.75 down here, and you've got perfect score GPAs like 4.0 over here, and you've got your nice attainable GPAs 2.75 and 3.0 here in the middle. I want you to notice that there are lots of kids who are getting these good, healthy GPAs of 2.75 and 3.0. There are only a few kids who are getting low GPAs of 1.75 and 2.0, and there are only a few kids that are getting very extremely high GPAs of 3.75 or 4.0. This is what is average. This is what is normal. Over here, what we have is we have another graph, and this one is about household income, and it happens to be for a country that is not the United States. We have the number of individuals or families that are reaching that, and once again, I want you to notice that it looks like there are a lot of households that have incomes that are in this range. This would be your nice working middle class people right here. These people over here would be the people that you might consider the rich people. And over here, you might consider these ones the poor people. They don't have that much money to live off of. And so that you can see that in both of these graphs, there is this shape that is showing up. High in the middle and low on the sides. High in the middle and low on the sides. The shape is called a normal distribution, or it is also called a bell curve. This bell curve affects lots of things in your life, and you can use it to predict the future quite often, because most things follow a bell curve. The bell curve is usually, once again, low on the sides. These are going to be the most extreme cases: the very poor, the very rich, the very smart, and the students who struggle the most. And you're going to have these people here in the middle where it is going to be the highest, and that is going to be your normal people, where the mean, the median, or the mode would be. Because the shape is so popular, it becomes very predictable, and what you can do is you can find out exactly how many people are underneath portions of this bell-shaped curve. And so we are going to take a look at that right now. After many, many years of studying these curves, statisticians found that when you're looking at the curve and you consider everyone that exists within that curve, everyone that exists would be considered 100% of the population. If you start here in the middle with your mean and you travel one standard deviation out to the right and to the left, that standard deviation will create an interval of people, and that will be at the highest part of the graph. 68% of the population will live within one standard deviation in this high peak portion of the graph. Now, if you extend out not just one standard deviation, but two standard deviations, now what you're going to do is you're going to be looking at this highest peak of the graph, but also this downslope as well on both the right and on the left. That means that you will have collected 95% of the people. This is almost everybody that is going to be participating in a given activity. If you go 3 standard deviations, 1 standard deviation, 2 standard deviations, 3 standard deviations, you will now have included 99.7%. Most people, almost everybody, is within 3 standard deviations of the mean. When you go past those 3 standard deviations out here, this is where your most extreme cases are. This is where your outliers are. There are only very few of them, and they are rare and strange in comparison to what is happening here in the middle. Now, these numbers are super, super helpful, but in order to make them even more helpful, what I've done is I've actually split them all down. So our 68 right here that I had talked about, that 68 was when you moved both to the left and to the right. And so what I've done is I've split that 68 into 2 34s for you. And the 95 right here, what I've done is I've taken the 34s out and I've split the remaining. So this guy, this guy, this guy, and this guy will add up to give you that 95. This version of the graph is more helpful, and it's the one that we'll use more often. This version of the graph is the best way to introduce the material to you. Okay, so now let's bring these two things together. Let's bring this goofy little graph that we made up here at the top and this new graph that we collected right here together. What I have right here is a very typical homework question, and it is asking about a normal distribution. And what we're going to do is we're going to present you with this crazy fact, and then we're going to ask you to see if you can come up with an answer for it. Now, if you look carefully, you're going to see a bunch of things, which is immediately a bit alarming, but when you look more carefully, you'll start to see things that you're very familiar with. So let's go through. To begin with, P is an old friend. Capital P usually stands for probability or percent. And so today, it's going to be both. We're going to be writing our answers as percentages. We're going to be getting all of our percentages from this graph right here. Next, X bar. You see a couple of X bars, and they are mean. You'll also notice that X bar showed up quite often in our graphs that we've seen so far, and so that is not a new or crazy symbol. It is very, very common. Lastly, sigma. Sigma means standard deviation, and that one also shows up in our graphs quite often, and so you are going to be using that. Now let's see if we can answer the question. So follow along with me. This is a little tricky, but it gets very easy very quickly. It seems very foreign at the beginning, but it moves very, very simply. What we are going to do is we are going to be looking at these two pieces of information right here that are on either side of our variable, which is just regular normal x. I want you to try to locate these two pieces of information on our graph, and they are going to serve as the borders. So one of them is just plain old X bar. There are lots of X bars, but most of them are paired with another term that has a sigma. We just want the plain old X bar, which is going to be this guy. He represents this very tall line right here, or this very tall fence border. The other one we want to find is X bar plus 3 sigma. Now you can find the 3 sigma on the left, but it has a minus sign. You want the plus one, so we're going to be choosing this X bar plus 3 sigma over here on the far right, and he represents this very short fence border. Okay, so now, just like at the top of the graph, do you remember when we drew our dots? We didn't stop there. We also shaded in the middle. So we're going to do the same thing here. Our variable x is in the middle, so we are going to be shading in the middle. That means that we're going to be shading 3 different sized bars, and we're going to be looking at each of those bars. Now, each bar that we have shaded is actually assigned its own specific percent, and those percentages never, ever, ever change. They're all listed for you right here. This tallest bar that we shaded right here will always be the same as this tallest bar, which is 34%. This medium height bar that we have right here will always match this medium height bar, which is always 13.5%. And this short bar right down here will always match with this short bar right here, which will always be 2.35. Now, we shaded all three of those bars, which means we want all of them. And the way that we're going to get all of them is by adding them together. So we're going to take our 34, and we're going to add the 13.5 to it, and we're going to add the 2.35. Adding these percentages will tell you what percent of the data lives in this portion of the curve. When you add those up, you get an answer of 49.85. Please do not round in any way. Put your percent sign on there, and you're good to go. Something quick that I want you to make sure you're clear on is that we did not shade on the other side of any of our borders. We did not shade over here to the left of our line, and we did not shade over here to the right of our border either. We made sure that all of our shading happened between the x bar and the x bar plus 3 sigma, in between them. Not over the top of them, but in between them. These are the fences. They are not the spaces in between. Let's practice a couple more. So right up here at the top of the next page, we have a couple more of these, and I wanted to practice those with you. Please pause your video right now and see if you can answer these two questions, and then I will give you the answers in a couple moments. Here are the answers to your two U-try-it problems. So this one is a little simpler, and it says x is less than or equal to x bar minus sigma. So you find the x bar minus sigma over here on the left side, and because it's less than, you are going to be doing every bar that is to the left of it. Less than is like an arrow that points to the left, so we shade to the left. Now what we're doing is we're using this small microscopic bar, this very small bar, and this medium-sized bar. These numbers that I've copied down are the exact numbers that we had from the front side. I'm going to add them all up, and I'm going to make sure I put a percent sign on my final answer. The second question is more similar to the example that we had done together. You'll find your variable x right here in the middle. You are going to be finding an x bar minus 2 sigma on the left and an x bar plus sigma on the right, and you will be shading in between these two border lines. Once again, the bars that we're using are going to have the same percentages as to what we saw on the front side. When you use those percentages and add them up, you get your answer. Make sure you put your percent sign on there. Okay, now the last and craziest kind that we're going to look at is this one right here. And I want you to notice that this one's got a new and fancy piece that says OR. Now, OR is interesting because OR means that you're actually going to be shading twice. You're going to split the problem. So in one case, it says x is less than x bar minus 2 sigma. Once you've found your border line, x bar minus 2 sigma, less than means go to the left, which means we're going to be looking at these two very, very microscopic, very small sections right here. Over our next one, x bar plus 3 sigma, that one is paired up with a greater than sign. Greater than means shade to the right, so that means we're going to be shading over here, another very microscopically small bar. Now, each of these bars has its own percentage, and once again, all of these percentages come from the front side. I am going to add up all of these percentages together. Even though they're shading on the left and then all the way over here on the right, I'm still going to add them all up as if they were right next to each other. So my 0.15 and my 2.35 from the left will get added with the other 0.15 from the right. And that is going to give us our answer of 2.65%. Please make sure you include your percentage sign. Please make sure you do not round. It doesn't matter If it is a greater than problem or a less than problem, or it has two less than signs, or it has the word or in it, you will always ever give me one answer, never two answers. Last example. Last example looks a little bit more complicated because it looks like there's a big fat story attached to it, but it's really not so bad. So this problem is once again going to give you some context. This is about the SAT exam in 2017. And what they're going to do is they're going to tell you a mean score for the test and a standard deviation, and then they're going to start asking about percents. Now, a lot of times people start to think this part doesn't have anything to do with this part, and they get confused. And the thing that connects them together is that so many people take the SAT that their scores start to look like a bell curve, and it becomes very normally distributed, which means that you can use those fancy percentages that we've been working with all along, these ones right here. The thing that we need to do, though, is we need to label our bell curve a little bit using the information that is given to us here. So let's do that. Right here in the middle of the bell curve is where we're going to start, and we're going to start with the mean. Average or mean always occurs in the middle. Smack dab, bullseye in the middle. Then, to fill in the values that are on the right and on the left, what we are going to do is we're going to now use our standard deviation. As we move further to the right, these are the people who are getting higher and higher scores on the SAT. And the way that we're going to move to the right and increase those scores is by adding 137 each time. So I'm going to add 137 repeatedly. That's going to give me 1187. And then I'm going to add it again, and that's going to give me 1324. And then I'm going to add it again, and I'm going to get 1461. Now these people over here on the left, these are the ones who got lower and lower scores on the SAT. And in order to figure out the scores they got, I am going to be subtracting 137. So as I start here in the middle with my 1050, I am going to subtract 137, which is going to drop me down to 913. And then I'm going to subtract 137 again, which is going to take me down to 776. And then I'm going to subtract one more time, which takes me down to 639. Now that is a complete bell curve and easy to work with. So let's answer some questions. My first question that I have says, about what percent of test takers scored between 776 and 1,324? It is no coincidence that the two numbers that are mentioned here are now two numbers that show up on my curve. I have labeled a 776 and I labeled a 1,324. What we want to know is we want to know about everybody that is between. So now this is where these problems start to become a lot better. Up here, we have all these crazy looking symbols, and it can be really alienating and scary. Down here, everything's spelled out nicely and clearly. You know what the word between means. It's not scary at all. And so that means that what we want to do is we want to look at these bars that are in between our two borders. There are 4 bars here, and each bar follows the same percentages that we had on our front side. This first bar is a 13.5. The second bar is a 34. The third bar is another 34. And the last bar is another 13.5. If we add all of those values together, we will get the percent of the population who took the SAT and got between a 776 and a 1,324. These would be the most quote-unquote normal people. These are the ones who got normal scores. Not too high, not too low, 95% of the population. Second question. So now this one says less than. So now less than 913. Here is my 913 right here. And less than means I need to go for the scores that are lower. So you can see those lower scores written down right here. So I want all of these people who got really low scores. Each of these people has a percentage attached to them. We have our 13.5 for our medium-sized bar, our 2.35 for our small bar, and our 0.15 for our microscopic bar. When we add up those values together, we are going to get the percentage of people who didn't do so great, not so hot on the SAT. And luckily, there's only 16% that didn't do so great. Last question is one that I want you to try on your own. It has the word or on it. That means you're going to shade twice. Please pause the video now, and then I'll share the answer once you're done. 636 is all the way over here on the far left. And 1,461 is all the way over here on the far right. That leaves us only these little tiny tails on either end to add up. 0.15 plus 0.15 is 0.03. Please don't move your decimal on this one. This is as good as it gets. Okay, that is video 1 of 2 on section 11.1. Please watch the second video.